All right, so we are on to chapter 7 here with costs and cost minimization. And what have we learned in class on this? Let's just take a look. So in class, we were talking about the cost functions here and finding the optimal points with those, and also this duality thing with Shepard's lemma and stuff. So the first thing they talk about is costs and how it's not always just money you're doing, because we have explicit costs, which are costs that involve direct monetary outlay, and then implicit costs that don't involve cash necessarily. So like an explicit cost of an airplane would be its fuel and maintenance and stuff, but the implicit cost would be the opportunity cost that they have for not lending the plane to someone else that can use it. And remember, we have opportunity cost, value of the next best alternative. They say that opportunity cost is forward-looking. Forward-looking. And the reason for that is if, say you have the steel producer here, and they bought some sheet metal for $1 million, and then the price goes up to $1.2 million. So the opportunity cost of them using it instead of selling it is $1.2 million, not just $0.2 million, because we're forward-looking. We're not talking about this in the past. Then we have economic versus accounting costs, and economic costs are the sum of the explicit and implicit costs, and accounting costs are just those explicit costs. Then we have sunk costs and non-sunk costs. Remember, sunk costs is like if you're going to see a movie and you already paid the $7.50 say to get in, and you decide you want to leave, but you're like, oh, but I paid $7.50, but you already paid it regardless, so it's a sunk cost. So non-sunk costs do change if a decision is made, and sunk costs do not change whatever decision you make. All right, now it's time for the cost minimization problem, which I'm guessing is going to look similar to this thing we were working on. So remember, we have the long run and the short run, and the long run is where there's at least the short run is when at least one of the costs is fixed, and then so in the short run, at least one of the inputs is fixed, and then in the long run, the firm can vary any of the quantities of inputs. So we have a bunch of ISO cost lines here. And notice this right here. So we could do E or F along this, but you're going to get the same amount of quantity, and it's going to have a higher cost. So you might as well just maximize it here. Where's tangent? And use this tangency condition right here. This one, there's a corner point. You find it where it intersects the axis like this. It seems easier to find the corner solution with these because you have this isoquant here, and then you see that in order to get to this isoquant, you just choose this budget line, which is the lowest cost, so it's going to be there. So if we have two conditions where the isoquant is smooth and also that there's no kinks in it, so we don't have a corner point solution, and there's also not a fixed proportions thing or something like that, then when the cost of one of the inputs is going to increase, we're just going to shift our cost line and end up being at a different point on the isoquant. See if we have a kink or something like this, just kind of stay at the same point. So when we increase the quantity here and we find the optimal points, when we connect them, we get this path called the expansion path. And kind of like the, what's it called? Kind of like an angle curve. If it has a positive slope, the expansion path, then it means that the inputs are normal inputs, which means if you use more of them, you get more output. And if they are inferior inputs, which means you use more of it and you get less output, then you're going to get a negative sloping expansion path. And we can have something called the input demand curve. So we have a labor demand curve here where we'll see there's two possible things. Let's say at first that we keep this quantity fixed right here. So its quantity is going to be 100, and then the price of labor is going to increase. So then we're going to get from this A line to this B line, but it's going to have to stay on this. So this is going to be our new point B. But then if we keep the price of labor the same, so we're going to have the same slope, right? But we increase the output to 100 to 200. So if we go from A to B, it's just going to be a movement along the demand curve because it's just a change in price, right? But then if we actually shift it out to here, what we increase the output, that's going to shift the whole labor demand curve out. Similarly, we can use a capital demand curve. So then now we have these demand curves. We can do a price elasticity for them. So price elasticity is going to be with the wage, right? And then that L is going to be the quantity, right? So remember, it's just delta Q over change in quantity, change in price times price over quantity. And then same thing for the capital. And we have elasticity with respect to the price, which will be the rental rate. It's the change in quantity or change in price times the P over Q. This is what these mean. So if it's very inelastic or a low elasticity substitution. So this is just showing that whether it's elastic or not is going to depend on if it's a high or low elasticity of substitution. So if we have a low elasticity of substitution, then it's going to look like this, right? And then so when we increase so when we increase the wage rate, it's not really going to change the whole quantity of labor a whole lot. If we have a high elasticity of substitution, then that means if we increase the cost of labor, then it's going to decrease the quantity by a lot. So that was the long run. So we're going to look at the short run now. So then we have the total variable cost and total fixed cost, because now we have some kind of fixed cost in here. So we have to deal with sunk and